Algebra 1, Lesson 113. We are looking at the discriminant, which is part of the quadratic formula that we looked at just a couple lessons ago in order to decide how many different solutions does a quadratic have. This tells us how many roots. It doesn't actually tell us which are the roots. We could go a little bit further with the quadratic formula to do that, but it just tells us how many we have, which is important to know. So let's remind ourselves about the quadratic formula. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a little song that goes with this. I think I showed it in the video about that, so you can go back and remind yourself of it. It goes along with Pop Goes the Weasel, but negative b plus or minus the square root of b squared minus 4ac all over 2a. So what is the quadratic equation form? This is reminding us that we have a quadratic equation, and I'll put it as f of x equals ax squared plus bx plus c, reminding us that we can get a, b, and c from that quadratic equation that we are given. So our discriminant helps us determine the number of solutions in a quadratic expression, but we're only looking at part of the quadratic formula, and that is part that's underneath our radical sign, b squared minus 4ac. As you can imagine, if we were to put different potential numbers in there, this comes out differently each time. So for example, if I were to put in some numbers and I ended up simplifying to something like the square root of 36, the square root of 0, and the square root of negative 3. Well, each one of these would actually tell me something different about this quadratic. With this first one, it would tell me that I would have two different roots. The reason for that is because of this plus or minus that comes before the radical. So actually I have plus 6 and I have minus 6 coming from that radical. This next one, square root of 0, if I have plus or minus square root of 0, I'm still going to just have 0, so I actually only have one root. So we have two roots, we have one root, and then as you can imagine, we have 0 roots with this last one because this ends up being not a real number. It's imaginary. I can't spell this more. There we go. Okay, so we have an imaginary number there because we can't take the square root of negative 3, meaning that in our real number system with those quadratics, we have 0 roots. And this is what we're looking for with our discriminant. So let's actually put that into practice with a few different ones. So looking at this quadratic, looking at a graph of it, we would assume that we would have two solutions because we have two x-intercepts. So using our discriminant, let's make sure that's true. So b squared minus 4ac. Well, in this case, a is, well, there's a little 1 in front of that x squared. B is negative 4, and c is 3. So let's plug those in. We have b squared, so negative 4 squared, minus 4 times 1 times 3. So we get 16 minus 12, so we get 4. Since that's a positive number, we are going to have two roots. Because when we actually take the square root of it, we're going to have a plus 2 and a minus 2 to work with in order to get my different solutions. And of course, go back to that lesson about the quadratic formula if you're not quite remembering what I'm talking about with that plus or minus. All right, let's see if we can determine if this graph really does show us the truth or not. Okay, so b squared minus 4ac, let's plug it in. So in this case, we have a negative 4 squared as our b, minus 4 times 1 times c is 4. So in this case, we get 16 minus 16 is 0. Since it doesn't make a difference to do plus or minus 0, we just have 0. So that is just one root. It doesn't mean that 0 is our root, it just tells us that there's only one root, and we can see that in our picture. Just one x-intercept. All right, how about this next one? B squared minus 4ac. We're looking for potentially no roots based on the picture. So we have b squared, so negative 4 squared, minus 4 times 1 times 5. We get 16 minus 20. That gives us a negative 4. Since if I were to take the square root of negative 4, it would give me an imaginary number. I have 0 roots. And that's true based on that picture. Okay, so just to make sure that we're writing this down as far as where we're getting all of these numbers of roots, if our discriminant ends up being less than 0, that gives us the square root of a negative number, so that can't happen in the real number, so there are no real solutions. We have 0 roots. If our discriminant is 0, then we have only one real solution. It just comes down and touches the x-intercept once. We actually call this a double root, okay? Just a kind of fancy way to say that we just have one root, and when we look at it, it's technically a double root, since it represents both of our potential roots. Lastly, if we have something that's greater than 0, then we have our typical quadratic, and there are 2 real solutions. It crosses completely twice. So let's figure that out with these ones here. Without actually solving, so we're not actually going to find the roots, find how many solutions. So just like above, we're going to use b squared minus 4ac for each of these. For this, I'll just do a couple of them. So b squared minus 4ac, my b is negative 3 minus 4 times 1 times 9. And so we get a positive 9 minus 36. Looks like that's going to come out to a negative number regardless, so I get no roots. All right, let's do this. 2x squared minus 3x minus 4. So I get b as negative 3. So negative 3 squared minus 4 times 2 times negative 4. So we get 9. And then we have a negative and a negative here, meaning we're going to get a positive number. So plus, that looks like 32. That's a positive number, so we're going to get 2 roots. Okay, you can go ahead and try the other true for yourself to figure out how many different solutions do you have, and you can always graph these quadratics to prove if you're right or not with the different roots. Okay, I'll just do one of these. I'll do this first one. So b squared minus 4ac. I have 2 squared minus 4 times 2 times negative 5. So I get 4, and then we have a negative negative, so that's plus a 40. So we're going to get 2 roots. Don't know what the roots are yet. We could continue the actual quadratic formula to figure out what they are, but we get 2 roots. I'll go ahead and do this next one as well. And I will get 2 squared minus 4 times 1 times 1. And we get 4 minus 4, which is 0, so I get only 1 root. Remember, I can take the square root of 0. I'm just not going to have 2 different solutions for that, so I only have 1 root. Now, this can actually come into play with real-life situations. You'll see things like this, and you can use the discriminant to actually solve this. So it says a baseball is thrown in the air with an initial velocity of 20 feet per second from 5 feet off the ground. Use the equation h equals negative 16t squared plus 20t plus 5 to model the situation. Will the ball reach a height of 30 feet? Now, we could go ahead and use our axis of symmetry formula and plug that in to find our vertex to see if that's bigger or smaller than 30 feet. Or we could just use the discriminant. We just have to do one thing beforehand and say, let's see if h is 30. So we plug in 30 as h. And now we have negative 16t squared plus 20t plus 5. Now you'll notice from all of the rest of the problems that we've been doing, this left side has always been 0. So I'm actually going to subtract 30 from each side to get everything on the other side. So now I can actually use the discriminant. And I'm going to plug it in, and I'm going to say b squared minus 4ac. If this has a root, then we would say yes, it's actually going to reach that height of 30. If it comes out with no roots at all, we're going to say no, it can't reach that height of 30. So let's plug it in. We have 20 squared minus 4 times negative 16 times negative 25. This is not looking so good with all those negatives. We plug it in and we get 400 minus 1600. Well, that comes out to a negative 1200, so we have no roots, meaning that this is not going to get up to a height of 30 feet. It's not going to reach that because there are no solutions to this quadratic. All right, now I have a couple more examples down here that you can try for yourself. Same situation as above. I'll give you a little hint with this one. When we have 45 feet per second for our initial velocity and 5 feet off the ground, we would say our equation is something like h equals negative 16t squared, showing our gravity, and then our velocity of 45 feet per second, and then 5 feet off the ground. So we would want our h to be 30 in this case. So plug it in, see what you think happens. And same thing with that football. Will it reach a height of 45 feet? Take a second to try that out. All right, well, I hope that this lesson helped you with those discriminants and figuring out if we do actually have 1 root, 0 roots, or even 2 roots for our quadratics. All right, I hope this helps with your homework and for studying.